Hello students, in the last class we have discussed about some basic properties of inverse trigonometric functions. Today we will discuss some more properties with examples. So first one, sin inverse 1 by x is equal to cosec inverse x when domain is x modulus of x greater than equal to 1. And second one, cos inverse 1 by x is equal to sec inverse x, domain is again this modulus of x is greater than equal to 1. Number 3, tan inverse 1 by x is equal to cot inverse x and x is greater than 0. So these domains are there. This is true. These properties are true only when this domain is there. I'll just go through this property. Okay, before this, let us prove any one of these. How to prove it is very easy. So the proof goes like this. Proof number 1. If we take the proof of number 1, it is in the book also. So let me explain only. So this is let, we start like it, let sin inverse 1 by x is equal to say theta. Sin inverse 1 by x is equal to theta. So this implies sin theta is equal to 1 by x. So this implies cosec theta is equal to x. So this implies cosec theta is equal to x. So this implies cosec inverse x is equal to theta. But theta is equal to what? Sin inverse x. So therefore sin inverse x is equal to sin inverse 1 by x is equal to cosec inverse x. See, sin inverse 1 by x is equal to x is theta. So this implies sin theta is equal to 1 by x by definition of inverse trigonometric function. So sin theta is equal to 1 by x. So therefore perfect theta is equal to x. So sin theta is equal to 1 by x. So cosec theta is equal to x. So this implies cosec inverse is equal to theta. But theta is equal to sin inverse x. So sin inverse x is equal to cosec inverse x. In this way, in the same way, we can prove these properties as well other two properties also. And this will happen in this domain only. Next, let us do next property number 2. This is also important. Number 2, property number 2, sin inverse minus x is equal to what? Sin inverse minus x is equal to minus sin inverse x. And of course, x belongs to those interval minus 1 plus 1. Number 1. And number 2, second, it is grouped where a minus sign is getting out directly. It is grouped for those sin inverse minus x equal to minus sin inverse x, and then cosec inverse minus x is equal to minus cosec inverse x, and the domain of cosec inverse x is x modulus of x is greater than or equal to 1. And number 3, tan inverse minus x is equal to minus tan inverse x, and domain x is the whole set of R. So the proof is same as the earlier one, we'll choose sine inverse of minus x. Say sine, any one of them. So let us try which one. Say let us try this one. Sine inverse minus x is equal to minus sine inverse x. We put, let sine inverse of minus x is equal to say theta. So this implies, by definition of inverse trigonometric function, sine inverse minus x equal to theta implies sine theta is equal to minus x. So this implies x is equal to minus sine theta. So this implies x is equal to minus sine theta. We can write it as sine of minus theta. Sine of minus theta. So this implies sine inverse x is equal to minus theta. But theta is equal to sine inverse minus x. So this implies sine inverse x is equal to minus sine inverse minus x. And if we multiply both sides by minus sign, then minus sine inverse x is equal to sine inverse minus x. So we have proved. So sine inverse, therefore sine inverse minus sine inverse x is equal to sine inverse of minus x. So it is proved. So therefore it is proved. Similarly, we can prove the other two properties as well. Next type is another type, this type of property, and that is what we can if number 3, number 1, cos inverse minus x will, what is written, cos inverse x minus x, it is equal to pi minus cos inverse x. X belongs to close interval minus 1 plus 1. And number 2, cos inverse sec inverse minus x is equal to, this will also pi minus sec inverse x. X belongs to, modulus of x is greater than equal to 1. It must be greater than equal to 1. And third one, cot inverse minus x is equal to pi minus cot inverse x. And here x is any proof. Same way. And the proof same way we can do, say this one. So this one, let us solve this one. So how do we start? Let cos inverse minus x is equal to theta. So this implies cos theta is equal to minus x. So this implies cos minus cos theta equal to x. So this implies minus cos theta can be written as cos of pi minus theta is equal to x. We cannot write here, we cannot write cos minus cos theta is not equal to cos of minus theta. It is not correct, because we know minus cos theta is not equal to cos of minus, because cos of minus theta is equal to cos theta. So we cannot write. In case of sine, we have written it, but in case of cos, we cannot write. So minus cos theta, we should write cos of pi minus theta, then cos inverse x is equal to pi minus theta. So this implies theta is equal to pi minus cos inverse x. So this implies we have got our identity. Now theta is equal to cos inverse minus x. So in place of theta, if we substitute this cos inverse minus x, so therefore cos inverse minus x is equal to what we got? Pi minus cos inverse x. So in the similar fashion, the remaining two properties can be proved. After that, next property is like this. Next property, let us discuss the next property. Property number 4. This is also very important property number 4. Property number 4. 1. Sin inverse x plus cos inverse x is equal to pi by 2, and obviously x belongs to minus pi by 2 to plus, x belongs to minus 1 plus 1. It's interval minus 1 plus 1. Number 2, sin then tan inverse x plus cot inverse x is equal to again pi by 2. This is true for any x belongs to R. For any real number, this is true. Tan inverse x plus cot inverse x is equal to pi by 2. And third property is sec inverse x plus cosec inverse x is equal to pi by 2, and this is true when x modulus of x is greater than equal to 1. It's true only when x is greater than equal, modulus of x is greater than equal to 1. So we can prove. Anyway, let us try this one. Tan inverse x plus cot inverse x is equal to pi by 2. We try to prove this one. Our aim is to prove tan inverse x plus cot inverse x equal to pi by 2. So we start with any one of them. Select tan inverse x is equal to theta. So this implies tan theta is equal to x. Now we know by complementary angle formula we can write tan theta can be written as cot of pi by 2 minus theta is equal to tan theta. Cot of pi by 2 minus theta is equal to tan theta. So in place of tan theta we can write cot of pi by 2 minus x. So cot of pi by 2 minus theta is equal to x. Now by definition of inverse trigonometric functions, cot inverse x is equal to pi by 2 minus theta, but theta is equal to tan inverse x. So you can write this as cot inverse x is equal to pi by 2 minus tan inverse x. So this implies tan inverse x plus cot inverse x is equal to pi by 2. So this is true for any real number. This is true for any real number. X belongs to R. This is true for any real number. Tan inverse x plus cot inverse x is equal to pi by 2. So in the same way, remaining two properties, the remaining two properties can be proved. So you must try to prove the properties yourself. Then next, fifth one, 5. Number 1, tan inverse x plus tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy, and here modulus of xy is here, xy is less than 1. Xy should be less than 1. In that case, this is applicable. So you have to remember that if xy is less than 1, then only you can apply this formula. Xy must be less than 1. Product of x and y must be less than 1. And then only you can apply this formula. Okay, very careful. This formula can be applied only when xy is less than 1. In examination, you have to check before applying this formula whether xy is less than 1 or not. In most of the cases, the questions are set in such a way that xy is less than 1. If it is not less than 1, then you have to make it less than 1. And that technique we learn how to make it less than 1. So tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. Second property is just replace this tan inverse x minus tan inverse y is equal to tan inverse x minus y divided by 1 plus xy. And here xy is greater than minus 1. Here xy should be greater than minus 1. Product of x and y should be greater than minus 1. You have to ensure it. And third one, twice tan inverse x is equal to twice tan inverse x is equal to tan inverse twice x by 1 minus x square. Tan inverse twice x by 1 minus x square. Tan inverse 1 twice x by x square and modulus of xy is here less than 1. Then you can apply. Modulus of xy is less than and modulus of xy is less than 1. Then you can apply this formula. So let us try to prove these are important properties. So let us try to prove one by one. We will prove, say first one, let us try. It is in the book, so let me quickly prove this one. In the book also it is there. So still, let me explain how we are doing. What is the technique? You have to take this one as one alpha, beta, a, b, anything, which is we will choose this as another one. So let proof let tan inverse x is equal to alpha, tan inverse y equal to beta. So this implies tan alpha equal to x and tan alpha beta is equal to y. We know tan of alpha plus beta. Why are taking alpha plus beta? Because this is alpha and this is beta. You see alpha plus beta is involved. So you have to find out alpha plus beta. So tan of alpha plus beta is taken. Tan of alpha beta formula we have in the class 11. We have studied tan of alpha plus beta is equal to tan alpha plus tan beta divided by 1 minus tan alpha tan beta. This we have studied in class 11. So this is equal to, just now you see tan alpha is equal to what? X. So we can write it as x and tan beta is equal to y. So x plus y divided by 1 minus xy. So by definition of inverse trigonometric function, we can write now Therefore, alpha plus beta is equal to what happens? Therefore, alpha plus beta is equal to tan inverse x plus y divided by 1 minus xy, as this proof. So in this way, so now this implies alpha is equal to what? Alpha is tan inverse x. Alpha is tan inverse x. Alpha is tan inverse x, and beta is tan inverse y. So tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus x. And domain, no need to write, you can check it, but no need to write the domain. That xy less than 1, it is obviously there, it should be there. Next is tan inverse x minus tan inverse y. Simply you substitute here in place of y. If we substitute simply by minus 1, then also you can prove. And last one was twice tan inverse x is equal to tan inverse twice x by 1 plus x squared. So these are very important. Tan inverse x is equal to this one. So we start with like this. Tan inverse x is equal to tan inverse x is equal to say theta, which was like this. Let tan inverse x is equal to theta. Since tan inverse x is equal to theta, here 2 theta is there. So we have to write the formula for tan to theta. We know. Yeah, this is very important. We know which formula we have to use. We have to use tan into theta. We know tan to theta is equal to what? That we have to. Before that, we write here tan inverse x is equal to theta. So this implies x is equal to tan theta. X is equal to tan theta by the definition of inverse trigonometric function. X is equal to tan theta. Now tan to theta, the formula for tan to theta is twice tan theta. In the class 11 we have proved it. Twice tan theta divided by 1 minus tan square theta. So this is equal to now 2 tan theta. Tan theta is equal to x, so numerator becomes twice x, 1 minus. Now tan square theta. Tan square theta means x square. Tan square theta, tan theta is replaced by x, so it becomes x square. So twice x divided by 1 x square. So that means tan to theta is equal to, therefore tan to theta is equal to this one. So this implies 2 theta is equal to tan inverse twice x by 1 minus x square. So we have arrived at our result. We have arrived. So this implies we have got after this, in place of theta, if we substitute tan inverse x, so it becomes twice tan inverse. In place of theta, we have substituted tan inverse x, then 2 tan inverse x. 2 tan inverse x equal to tan inverse twice x by 1 minus x square. So hence it is proved. So these properties are proved in the same way. Other properties can be proved. Many properties are also there. So those we will discuss one by one now. One or two more properties we are going to discuss now. Sixth one, 2 tan inverse x is equal to sine inverse twice x by 1 plus x square. Number 1. Number 2, 2 tan inverse x is equal to cos inverse twice x by 1 minus x square by 1 plus x square. 2 tan inverse x is equal to sin inverse twice x by 1 plus x square, where modulus of x is less than 1, and 2 tan inverse x is equal to cos inverse 1 minus x square by 1 plus x square, where x is greater than or equal to 0. So we'll try to prove one of them, any one of this. Let us try the first one. Let us try to prove the first one. So similar in the same way earlier. So we can write like this: let tan inverse x is equal to tan inverse x is equal to what we can write? Theta. So this implies tan theta is equal to x. So here it is 2 theta is there, and here it is sine inverse. So we have to find out sine 2 theta. We will write the formula. We know here, because sine inverse, it is tan inverse is expressed in terms of sine inverse. So sine inverse here, sine inverse. So sine, this is 2 theta to tan inverse x. You see, tan inverse x, if we choose tan inverse x as theta, then it becomes 2 theta, and sine inverse is there. So we have to find out the sine 2 theta. So we know sine 2 theta is equal to what? Sine 2 theta. The formula for sine 2 theta in terms of tan theta, it is there. It is equal to 2 tan theta divided by 1 plus tan square theta. This formula we have studied in class 10. Or if you forgot, then you can quickly work out it here. Sine 2 theta, I think this you remember, still 2 sine theta cos theta, sine theta cos theta. So if we divide both numerator and denominator, divided by, we can write it like 2 sine theta cos theta divided by cos square theta plus sine square theta. 2 sine theta plus, because cos square theta plus sine square theta is equal to 1. Now if we divide the numerator and denominator both by cos square theta, then we get the identity, required identity. What is that? If we divide both numerator and denominator divided by cos square theta, then this cos theta will cancel, so it will become 2 tan theta, and cos square theta divided by cos square theta is 1, and sin square theta divided by cos square theta is tan square theta. I hope you understood. Okay, let me write it down here itself. Let me elaborate it here. So 2 sin theta cos theta divided by cos square theta, and here cos square theta divided by cos square theta plus sin square theta divided by cos square theta. So you see cos theta, this is cos square theta, this cancels, so it is 2 sin theta by cos theta, which is equal to 2 tan theta, and here it is cos square theta by cos square theta is 1, and sin square theta by cos square theta is tan square theta. So this was in the class 11. So here it is not the question, so we are not going to prove it. Simply we write directly the result, that is 2 tan theta. We know sin 2 theta is equal to 2 tan theta divided by 1 plus tan square theta. Now, as we have written there, 2 tan theta is, because tan theta is equal to x, so we can write it as twice x, 1 plus tan theta means x, so tan square theta is x square, so twice x by 1 plus x square. So this implies you see 2 theta is equal to sine inverse twice x by 1 plus x square. So we have arrived at our result. Theta is tan inverse x, so 2 tan inverse x is equal to sine inverse twice x by 1 plus x square. So it is proved. So it is proved. Now let us try one more. Last this class I will discuss one more. One more I will discuss. This is the question. 3 sine inverse x is equal to sine inverse thrice x minus 4x cube. And obviously there is one domain is there, that is material. It will be given there domain. It is in its domain only. So I am not writing a domain here. So how to prove this one? Prove this one. Prove it is in the domain. One domain is there in that domain. So domain is immaterial here. So it will be given automatically. It will be given in the question. In that domain only it will happen. So we start like this, the same way earlier. And earlier we have started sine inverse x equal to theta like that. So let proof, like the proof very easy. Proof let sine inverse x is equal to theta. So this implies sine theta is equal to x. So by the what definition of inverse trigonometric function, sine inverse x is equal to theta implies sine theta is equal to x. So now here you see 3 sine inverse x in the left side. So that means now sine inverse x is equal to theta. That means 3 theta is there. 3 theta. So we have to write this 3 theta is there. And here it is sine inverse. So this sine will write here. Sine theta. So this is equal to what we know. So we have to write, we have to know it. This is the class 11. Sine 3 theta is equal to what? Sine 3 theta formula is 3 sine theta minus 4 sine cube theta. So once you write this over complete. So now 3 sine theta. Now sine theta is equal to x. So 3 x minus 4 sine cube theta is, in place of sine theta we replaced it by x. Sine theta is replaced by x. So sine cube theta is equal to x cube. So we got sine 3 theta is equal to 3x minus 4x cube. This implies 3 theta is equal to sine inverse thrice x minus 4x cube. So this implies 3. Now theta is what? Theta is sine inverse x. So 3 sine inverse x is equal to sine inverse thrice x minus 4x cube. This will be happening in the S domain only. So thank you. I hope you understood.